Did you know that, in addition to being a multifunction furnace, dry block, stirred microbath, and black body, the TA-45NL can also be used as a water triple point cell maintenance bath? In this video, we will show how to realize the water triple point using the TA-45NL. To realize the water triple point, we will use water triple point cell, insert basket for housing the cell, upper thermal insulation lid, extractor for safe cell removal, analytical grade ethanol, TA, to fill annular spaces and act as a heat transfer medium, standard resistance thermometer connected to the TA-45NL auxiliary input for monitoring. Install the cell holder insert inside the TA-45NL. Carefully place the triple point cell into the insert, ensuring it is positioned vertically and securely. Fill the annular space between the bath wall, the insert, and the cell with ethanol, avoiding overflow. The ethanol acts as a heat transfer medium, improving uniformity and heat exchange efficiency. Insert the monitoring sensor into the well of the cell. This sensor will measure the internal temperature of the cell, not the bath temperature, which is essential due to the significantly higher thermal inertia of the water mass. Set the TA-45NL set point to 10 degrees Celsius to promote thermal equalization of the entire system. The exact value is not critical. It serves as an intermediate preparation temperature. Use the built-in data logger function of the TA-45NL to simultaneously monitor two signals, the internal sensor temperature of the equipment and the temperature of the sensor inserted in the cell. Carefully observe the generated graph. The fast response red curve represents the temperature of the block sensor due to the low thermal inertia of the metal. The slow response blue curve represents the temperature inside the cell due to the high thermal capacity of the water. Note the characteristic delay between the two curves. While the block has already stabilized at 10 degrees Celsius, the cell is still undergoing thermal equalization. This is precisely why the cell temperature must be monitored instead of relying solely on the bath reading. Once the stabilization trend of the cell curve at 10 degrees Celsius is observed, adjust the TA-45NL set point to -6 degrees Celsius to begin cooling. When the temperature inside the cell reaches approximately -3 degrees Celsius, the freezing process has already started. For these compact models, it is not necessary to wait for the bath temperature, but rather for the internal temperature of the cell. As soon as this condition is reached, carefully remove the cell from the TA-45NL using the extractor. Hold the cell firmly by its base, keeping it strictly vertical, and gently tap the top of the cell to one side. The ice will begin to form from top to bottom, and the temperature inside the cell will immediately rise to the triple point value. Carefully observe the interior of the cell during this procedure. Gradually, a descending frozen region will become visible, forming from top to bottom along the inner wall. This visual phenomenon indicates that equilibrium between phases is being established. Maintain the set point at -6 degrees Celsius for approximately 8 minutes. Add analytical grade ethanol at room temperature into the re-entrant well and gently warm the external surface of the cell with your hands. This combination promotes the release of the ice mantle, which should rotate freely inside the cell. After confirming the release of the mantle, return the cell to the TA-45NL. Adjust the set point to minus 0.3 degrees Celsius to preserve the ice mantle for extended periods, preventing both excessive growth and melting of the ice layer. Reinstall the monitoring sensor in the re-entrant well to follow stabilization. It is recommended to wait at least 15 minutes before using the cell for calibrations, allowing the system to reach thermal equilibrium after handling. During use, maintain a heat transfer medium with ethanol in the well and pre-cool the thermometers to be calibrated to avoid accelerated melting of the ice mantle. With the PRIA's TA-45NL and the proper procedure, the water triple point cell is correctly prepared and ready to serve as a primary temperature reference for your calibrations. Proper realization of the triple point combined with the versatility and performance of the TA-45NL ensures reliability throughout the thermometric traceability chain. TA-45NL, accuracy, versatility, and technology for your calibrations.